Okay, this is section 2.3, part 1, and we're going to talk about the product rule. So far when we're finding derivatives, we know the power rule, where we bring down our exponent and subtract 1 from the exponent. Well, now we're going to learn the product rule. Here's what the product rule would look like in your book. Okay, so let's look at this. The derivative with respect to x of f of x times g of x. So I have two separate functions being multiplied together. Here's the first one. Here's the second one. So this says the derivative is going to equal my first function, f of x, times, and then g prime of x, doesn't that just means the derivative of g, plus my second function g times the derivative of f of x. Okay, so this is what it would look like in your book, and you need to get used to seeing things like this and knowing what it means. F of x times g of x, here's what the derivative is equal to. Now, in real words, this is what you would do. The first term times the derivative of the second term, plus the second term. This should say times, plus the second term, times the derivative of the first term. All right, so let's do an example. All right, so I have h of x, and I have two things being multiplied together. So I'm going to use the product rule. So product rule says h prime of x would equal my first term, 3x minus 2x squared, times the derivative of the second. The derivative of 5 is 0. Derivative of 4x is 4. So here's the first times the derivative of the second, plus my second term times the derivative of the first. The derivative of the first is 3 minus, the derivative of this would be 4x. Okay? Now we could simplify all of this out. For right now, we're just going to leave it like this. All right? Now the other way we would be able to find the derivative, if I FOILed all this out, and I got, what would that be? 15x plus 12x squared minus 10x squared minus 8x cubed. If I FOIL all this out, now I can find the derivative using the power rule. So the derivative with the power rule would be 15 plus 24x minus 20x minus 24x squared. Now, why does this look different than this? Because they're supposed to be the same. Well, if I multiplied all this out, I would get that same answer. Okay, and I know I have like terms here. I could go ahead and combine. All right, so either answer would be correct, and you can do it either way. All right, so let's do another one. So find the derivative of y equals x, the quantity x cubed minus 4x times the quantity x squared minus 1. So I'm going to do this using the product rule. So here's my first term, here's my second term. Product rule says first term. So when you write that first term down, you need to put that term in parentheses. So first term times the derivative of the second, which would be 2x, plus my second term, x squared minus 1, times the derivative of the first, 3x squared minus 4. Okay, and unless I tell you otherwise, you can leave it just like that. All right, let's look at another one. Find the derivative of h of x. Now this time, this is 3x squared times sine x. So I know I'm going to use the product rule. Here's my first term. Here's my second term. Okay? So h prime of x equals the first term, 3x squared, times the derivative of my second term. The derivative of sine x is cosine x. So the first times the derivative of the second, plus the second times the derivative of the first. Derivative of the first is 6x. Now, when we simplify this, Okay, if I have like this 6x multiplied by sine x, we will always move that out to the front of our sine x. Remember, you can't multiply this x and 6x together. Those are completely separate things. So I would write my final answer like this. And that's what h prime of x is equal to. Okay, let's look at another one. Now they've introduced some new derivatives to you. So here are the new derivatives of some trig functions. The derivative of tangent x is secant squared x. Derivative of secant x is secant x tangent x. Derivative of cotangent x is negative cosecant squared x. And then derivative of cosecant x is negative cosecant x cotangent x. These are derivatives that you're basically going to need to memorize because you're going to need to know all these. So let's find the derivative. Now on this one, this isn't the product rule anymore. Okay, I'm not multiplying anything together. It's just x minus tangent x. So I'm going to find the derivative of each term. So the derivative of 1x would just be 1 minus derivative of tangent. Well, the derivative of tangent is secant squared x. Okay, now I'm going to leave it just like this. Later on, they may start simplifying your answers if it is a trig identity. So we're going to leave it like this for now, and then later on we'll look at our trig identities and see if this matches up to anything. Example 5. Find the derivative of x times secant x. So this time, this will be the product rule. Okay, here's my first term. Here's my second term. So y prime equals my first term times the derivative of my second term. Derivative of secant x is secant x tangent x. So the first times the derivative of the second plus the second times the derivative of my first. So that's just 1. Okay, and you can leave it just like that, or you can get rid of that 1 right there. Alright, so I just wanted to quickly introduce what that product rule was, and we'll go over more examples in class on Monday.